Hey guys, I've been getting some questions about these problems, so I figured I would do them for you and send them in a video to you. It would probably be a lot easier than just taking a picture, and I don't know if it helps at all to hear my voice, but this is our first problem. And this is just like a chain rule. If this were a W, we'd say the sine of W is the cosine of W times the derivative of what W is. And we would just use this formula of the arc cosine to find the derivative of that arc cosine of t. And that would become this. Where in this case, u is t, and the derivative of t is 1. So this is the chain rule, and this is basically our answer right here. But the cosine of the arc cosine of t is just t. So we'll just multiply this on top, and we get our answer there. Take a look at that one a few times to make sure you understand it. This one here, it looks long and ugly, but what we have is we have a product rule here. And look what's going on. We've got the first times the derivative of the second, which we use that formula to get this. And then we have the second one, which is the arc cosine of x, times the derivative of the first one, which is just a 2. So I don't know if you can see this, but that's where that 2x came from. First times the derivative of the second, plus the second times the derivative of the first. Then over here, we got a simple chain rule going on. This is really to the 1/2 power. We multiply it out front. They reduce. We reduce that exponent of 1/2 by 1, so it becomes a negative 1/2, times the derivative of what's inside, which is a minus 2x. These cancel out. Negative times negative is a positive. And we bring this back down to the bottom. And if you notice, this one and this one, they cancel out, leaving us with this as an answer. Pretty nice problem. Number 39, I actually did 2 different ways. And I'll just leave you to look at this, and you can follow this along. Actually, right here, this would be good enough on a test, because we don't want to do all this simplification. I got this as an answer. Then I decided to, well, what if I do this instead? You can take a good look at this or take a screenshot of that. But this is number 39, doing it an alternate way. What if I expanded this ln out to make it ln of x plus 1 minus ln of x minus 1 using that quotient log property to expand that? And then what we could do, then we'd have a 1/2 out in front of these, with a 1/2 out in front of the whole thing. And then I decided to distribute this 1/2 in and also this 1/2 in, and that's where I got these. And that 1/2 would also go inside to this. Take a good look at that one. This actually, believe it or not, makes the problem a little bit simpler. So when I take the derivative now, I'm taking the derivative, which is my y prime over here. I don't know if you can see that or not. My y prime. I got 1 over u times the derivative of u, which is just 1. So I got 1/4 times 1 over this, minus 1/4 times 1 over this, because that's how ln works when we take derivatives. And then we're going to use the formula for the tangent, which is the derivative of u, which is just 1, over 1 plus u squared, which is just x squared in this case. Now you can look at this. What I did was I found a common denominator. Now on a test, of course, this would be good enough. But this is, if you want to know what CalcChack does or the back of the book does, they found a common denominator. All of these, we adjusted the numerators. And when I multiplied them out, distribute the negative, I found out that everything cancels except for -1, -1, -2, which makes a -4, which reduces with the 4 on the bottom, and you get one of these 2 answers. And you can take a look at that, take a screenshot of that if you need to, and look at it very carefully. However, I won't have a test question where I'll require you to simplify it this way. So, good luck. That was the answer to some of your questions about 35, 37, and 39. Keep working hard. Another quiz next week, and then we'll be talking about maybe a different way to send these videos to you, and then also do a live chat. I'll talk to you soon. Bye-bye.